In this video, we're going to be converting two rectangular equations into polar equations. And up here, we have a little chart that's going to help our cause of taking things that are um, in rectangular coordinates or rectangular system, and we can use these substitutions to convert it into polar. So we'll start with y equals x squared. So just to kind of keep in the back of my mind, this is a parabola because we're going to throw this into the calculator to check. So we're going to eventually graph that. We know it's a parabola. We're going to throw it into the calculator once we shift it into polar, and then let's make sure it looks the same. So I can take this substitution that I have y and I have x. Well, y is going to equal r sine theta. X is going to equal r cosine theta. We're going to square that one. So we're looking at um, r sine theta for this equals r cosine theta, but it's going to be squared. So if I rewrite that, I'm looking at r sine theta is going to equal r squared cosine squared equals theta. Now we need to solve for r. So to solve for r, there's something that we're going to do that's not going to feel like we're heading in the right direction. We are actually going to divide both sides by r. So that would leave sine theta equaling r cosine squared theta, and we'll divide by cosine squared to get r by itself. So our equation is r equals sine theta over cosine squared theta. And that, if we graph that in the polar coordinate system, should create a parabola like we did in the Cartesian, the rectangular coordinate system. So I have my calculator, and I'm going to make sure that my mode is out of function notation and in polar. That's one thing I'm going to do. And I'm going to also make sure that I'm in radians. So if I go into my y equals, you'll see that no longer do we have x's, we have r's, or we don't have x's and y's. So it's not, we didn't solve for y, we solved for r. And if you notice that when we went to our mode, it was kind of the third option of different kinds of equations. And so on your variable button, it's the third variable. So when I put x on that, it's actually doing theta. So then here I am setting up this equation. I'll just turn on the equation. It should look like a parabola. And just so you know, my window, I went from 0 to 2 pi for my angle, so one period. And then, I don't know, that might have been in there, but I just did 0.1 if not. So just kind of a whole bunch of little incremental steps so it can graph a bunch of points. I went from -6 to +6 on the horizontal, the x's, and then -4 to +4 on the y's. And if I graph that, it looks just like a parabola as it's supposed to. So that is the equivalent form of in rectangular versus polar. And we'll do the exact same thing on this. And this one has it's the shape of a circle. And this center is shifted left one. So our center on that is left one up 0 with a radius. This is your r squared value, a radius of 1. Okay, so it's a circle that's left one and has a radius of 1. So it should look something kind of like that. So let's do that same kind of shifting, but let's get rid of some parentheses. Let's distribute this through. So if we distribute that through, that's looking like x squared plus a 2x plus a 1 plus y squared equals 1. The ones are going to go away. Oops. What I do see is I see an x squared and a y squared, which has a relationship that x squared plus y squared I can replace with r squared. So let me group those together. So x squared plus y squared, and then plus the 2x equals 0 is what's left over. So then I'll sub this with r squared plus 2 times x. X is r cosine theta. So r cosine theta equals 0. And then I'm going to do that same kind of weird feel that I'm going to divide every piece by r. So r plus 2 cosine theta equals 0. So if I shift it one more time, I'll just bump that over. And so my r is going to equal negative 2 cosine theta. And that should be my equation. So we're going to go back to our calculator and double check that that looks like a circle that has a center at negative 1, 0, and it goes 1 in every direction. You're supposed to go a little lower than that. So back to my quadratic. I have my second equation. Let me clear that one out. Turn that one on. So there's my negative 2 cosine theta. And if I press graph, I have my window. I didn't do anything to the window. I'll just press graph. And there's my circle centered at negative 1, 0, and it goes 1 in every direction. So that was converting rectangular equations into polar equations, and a calculator can definitely check and make sure things look like what they're supposed to.